Hello everybody, this is the notes for circumference of a circle and the arc length. It says area up here, but we'll talk about that, and I'll talk about that in a second video. So, circumference of a circle, I think you've all seen this equation before. We usually use 2 pi times the radius. If we don't know the radius, but we know the diameter, we could use pi times d. Pi is a number. It's called an irrational number. Where it comes from is you measure the circumference of a circle and divide it by its diameter. For any size circle, it's always that same ratio, pi. Now, it is approximately 3.1415. There are millions of digits. They don't know an end to those decimals. There's no repeating decimals to it. It's just numbers. It goes on for millions and millions of them. Don't use 3.14. Use the pi button on your calculator. It's going to be more accurate. Okay, so pi times the diameter or 2 pi times the radius. That gives you the circumference. The circumference is basically a perimeter. It is the distance around a circle. So from one point all the way around back to that same point. That's what a circumference is. Okay, so in this example, they're basic examples of just, we could do those basic examples of here's a radius, find the circumference. All you're doing is plugging it in, 2 pi times the radius. This one is a little bit more than that. All right, so my bike has a 26-inch diameter tire. I want to know how many revolutions does it take to complete a 6-mile bike ride. So the first thing we need to know is the circumference. How far does that tire travel when it goes around once? Now, at 26 inches, that is a diameter. So we're going to take pi times that number. I can bring up the calculator here. So I have 26 times the pi button is the secondary, and then the exponent button. 26 pi, so that is 81.68, and we'll leave all those decimals on the calculator, but that's inches. I'm trying to figure out, so the question is asking how many times does the tire go around? This is how far the tire travels when it goes around once, in inches. I'm doing 6 miles of a bike ride. So 6 miles, in 1 mile, there's 5,280 feet. So if we multiply those together, bring the calculator back up, 6 times 5,280. That is 31,680 feet. That's how far we're going. Each time the tire goes around, it only goes 81.68 inches. So what I'm going to do is convert that to feet. So I'm going to take my last answer, that 81.68, and I'm going to divide it by 12. 81.68140899 divided by 12. Every time that tire rotates, it goes 6.8067 feet. The 6-mile bike ride goes 31,680 feet. So the number of revolutions equals how far it goes divided by how far the bike travels with 1 revolution. So we do this division, 31,680 divided by that last answer. What? Oh, darn it. 31,680 divided by the ant. Why is it not doing the secondary button? Oh, I was bored. Divided by the secondary answer. There we go. The tire does 4,654 revolutions and a little bit more. Okay. So now, on to the next idea, arc length. We've talked about arc measure before, but now we're talking about the distance around a circle from a point to a point. So a little bit about notation. Okay, that's this right here. It's still going to be arc AB, same kind of notation with the arc above the endpoints of the letters, but when it says it equals, 10 centimeters, obviously that is a length. Sometimes it just says the length of arc AB. Other things that you're going to see is this. This is what we're used to, the measure of arc AB. When it's got that little lowercase m, we are talking about degrees. Okay? So we've got two different types of measurements. The measure of an arc is a degree. The length of an arc is a distance. Okay? So, to find an arc length of a circle, technically you got two formulas. This first one is a proportion that will always work. But just starting to talk about arc length, I prefer to look at this formula. Okay, so it says the arc length of AB equals. Now this fraction, it is the measure of arc AB. That's a degree. So basically, what we have is the measure of the arc divided by 360. That is just a fraction of the circle. Okay, for instance, if measure of arc AB was 180 degrees, we have 180 degrees out of the 360. So we're dealing with half of a circle. To get the arc length, we would take half that circle and multiply it by this 2 pi r. That's just the circumference. So if we're dealing with a 180 degree arc, that's half of the 360 degrees of the full circle. So you take that fraction, the 1/2, multiply it by circumference, there's your arc length. If it wasn't 180 degrees, let's just say, again, clean number, let's say it was 90. That's 1/4 of the circle. 90 over 360 is now 1/4. So we're looking at 1/4 of the circumference to equal the arc length. Okay, so this is the idea of an arc length. It's the fraction of the circle that you're looking at multiplied by the circumference, which is the distance all the way around. So, to answer these problems, if the question is just asking for what is the arc length, I would use that formula. If it's not, that's where this equal proportion comes into play. It says the arc length of the arc AB divided by the circumference. So we're comparing lengths. Arc length divided by distance around the entire circle, and that equals the number of degrees of our arc divided by the entire number of degrees of the circle, the 360. So let's take a look at this example here. It says find the indicated measure. So in part A, we are trying to figure out the circumference. Now, we know the arc length, that's the 8.62 or 6.82, and we know the arc measurement. Remember, the central angle and arc measure are equal to each other. So, we know the arc length. The question is, what is the circumference? So I'm just going to use that proportion. The length of the arc divided by the circumference equals the arc measure, which is 75, divided by the entire way around the circle, 360 degrees. Since we're trying to find the circumference, we don't need to plug in that 2 pi r. We just need to know what the circumference is. So we can just solve for c. So this is just a basic cross multiplication. 360 times 6.82 equals 75 times c. We're trying to solve for c, so divide by 75. Okay, and I'll let you figure out that number. 360 times 6.82, get an answer, divide by 75. For the second example, a little bit different. Okay, this is asking for the measure of arc AB. That is a degree. All right, that's what we're trying to figure out. So, what we know is this arc length right here is 40 feet divided by the entire circumference of the circle. Well, we're given a radius. So 2 pi times the radius, 15.28. All right, so, sorry, I had to hit pause there. We take the arc length divided by the circumference to equal the number of degrees. That's what we're looking for out of the whole circle, 360 degrees. So again, this is just a basic cross multiplication, sort of. Really just need to multiply by 360. Those will cancel out, leaving us with just x. But now what we got here is 360 times 40 over 2 pi times 15.28. All right, on your calculator, let me get the calculator back up here. Let me turn this off. Okay. On the calculator, if you're going to do this all at one step, you're going to do 360 multiplied by 40 divided by. You are dividing by this whole thing. So if you can do it all at once, you need to put this into parentheses. So 360 multiplied by 40, that is going to get divided by 2 pi times 15.28. Oh, didn't put the decimal in there. 0.28. Close that parenthesis. So the parenthesis is grouping all of that stuff, so that's what you're dividing by. Hit enter. X is 149.98, so basically 150 degrees. Okay? That's how circumference and arc length work. All those problems are basically the same. Concentrate on these two formulas. This one is going to be used when you're just finding arc length. The proportion works better for all the other problems. And you're just plugging in the things you know, solving for cross multiplying to solve for what you don't know. That's it. Have a good night.